Let's talk about bonds. All bonds have a par value. This is the amount the issuer will pay the bondholder on the maturity date. In this case, the issuer will pay $1,000 on June 1st, 2018. This bond has a coupon rate of 8% and pays semi-annually. This means the issuer will pay the bondholder 0.08 times 1,000 equals $80 each year, but it will make 2 payments per year. The issuer will pay the bondholder $40 every 6 months until maturity. These payments are called coupon payments because the bondholder would physically clip the coupon and bring it to the specified bank in order to receive the payment. To the potential buyer, this bond is a money machine. As a rule, it promises specific sizes and times of the cash flows. The investor evaluates the risk of the issuer not keeping the promise and decides what his money machine, the bond, is worth. The value of any money machine, financial asset, regardless of whether it's called a bond or stock or something else, is the present value of the expected future cash flows. Repeat after me. The value of any financial asset is the present value of the expected future cash flows.
Oh, you're serious. Sorry. Say that again.
The value of any financial asset is the present value of the expected future cash flows.
The value of any financial asset is the present value of the expected future cash flows.
So for this bond, we have a payout rule. Now we find the value by discounting the future cash flows.
What's YTM? I know it's the discount rate, but how do I know what the actual number is? And why do you call it K and not R like you do when we're finding the present value of annuities? By the way, this looks a lot like an annuity.
I wrote YTM because that's what everybody else does. YTM stands for yield to maturity. Most bond pros just say yield. It's also called cost of debt, so I could have written it KP, but I really could have written dog. I write the equation, I get to make the variable. The precise number depends on the potential buyer. If you have a high credit score, then you can borrow money at a relatively low rate to buy a car. If you have a low credit score, then you have to pay a higher interest rate on the car loan. Some folks can't even get a loan because of their credit rating. It's the same for a corporation. The higher the score the rating agencies give the firm, the lower the interest rate or yield you'll need to pay. Assume YTM equals 4.2%, and the price of the bond is $989.58. The coupon rate never changes. Visualize the old bearer bonds. If you own one, then the coupon payment is written in ink. It does not magically change. The discount rate changes. Investors looked at this bond, considered the risk, and compared it to other similar bonds issued by other companies or municipalities or the U.S. government. They decide the YTM should be 4.2%. New information could change their mind. Let's work through a bond problem together. A bond with a par value of $1,000 will mature in 4 years and make semi-annual payments. The first payment will be exactly 6 months from today. The coupon rate is 5%. The discount rate is 2.5%. What is the price of the bond?
First, I need to know when the cash flows occur and how much they are. The coupon payment is 1,000 times 0.05 divided by 2, which equals 25.
Why did you divide by 2?
Well, the payments are semi-annual. The discount rate is 5.2%, but that's in annual terms. So I need to use 0.052 divided by 2, which equals 0.026 in the calculation.
Why?
You always quote interest in annual terms. Since the cash flows are semi-annual, I divide by 2.
Perfect. Financial calculators were built specifically for problems like this. On the calculator, n equals 8 because there are 8 payments. Payment is 25. Future value is 1,000. And interest per year is 2.6. Now solve present value. Perfect. That's how you solve present value for a bond.